Back to our honors geometry video playlist. Here we're going to talk about some triangle congruence. So here we need to know what needs to be congruent for a pair of triangles to be congruent. I need to have all corresponding angle pairs need to be congruent, and all corresponding pairs of sides need to be congruent. So that's what we've been working with the last week or so, trying to prove that all of those matching sides are congruent and all of those matching angles are congruent. But today we're going to learn a shortcut, or two. We're going to learn about side, 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 and side, angle, side congruence. For side, 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 as long as we're able to prove that all three sides are congruent, we don't have to worry about the angles anymore. So if I were to try to copy this triangle, if I copy and paste it by copying all three sides, well, as long as all three sides are the same length, all three angles should match up too. And I can check that by picking one up and placing it right on top of the other. Because all the sides are equal, all the angles are also equal. Side, angle, side is a different shortcut we can use. And it says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are going to be congruent. So what does that mean? That means that if I have two sides and the angle where those sides meet, so if this is one side and this is one side, the angle has to be in between them. It has to be right here. Which is why they call it side, angle, side. Because I have two sides and an angle in the middle, and the name says two sides with an angle in the middle. So those two sides and angles would have to match up perfectly. They have to match up with the corresponding two sides and included angle. I always think of like cutting a pizza. As long as I cut this pizza with the same angle in the middle, then the pizza slices should be the same. If I start cutting with a big angle in the middle, I'm going to have different pizza slices. So, how can we determine which postulate, which shortcut we can use? If I look at these pictures, the first thing I want to know is, do I have any vertical angles or shared sides? I can always mark in vertical angles because they're always congruent. And I can always mark in these matching shared sides, these overlapping sides. And what I'm looking for is I'm trying to see, do I have two sides and an included angle? Well, here all I have is an angle pair and a pair of sides. So that doesn't help me. This one does not have enough information. All I have is one angle and one side. On B, I have all three sides are matching. Right? I have one pair right here. I have a second pair there, and I have my third pair, which is the matching pair. So this one could be side, side, side. I could also say that this is side, angle, side, because if we look at our triangle here, I have a side and a side with a right angle in between them, right here. And if I look at the other triangle, I have a side and a side, and if I use my knowledge of linear pairs, this must also be a 90-degree angle. So I could say that that is also an example of side angle side. I have two sides and the angle in the middle, in between those two sides. And C is just a good example of side, 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 because I have all three pairs of sides matching, congruent, and because I've got all three pairs of sides marked in, I've got side, side, side congruence. Okay, now, again, we can always mark in shared sides. So if I look at number 3, I can mark in shared sides. If I look at number 5, I can mark in shared sides. If I look at number 4, I can mark in shared sides. And if I wanted to, I could mark in any vertical angles, but there are no vertical angles here. So I'm going to ask you to please take a moment and try to identify if there's enough information to prove side, 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 or side angle side in any of these. So please try it, pause the video, and then when you're done, unpause the video and check your work. In this first one, I've got side angle side. In the second one, I've got side, side, side. In this third one, I've got side, side, side. This fourth one's kind of weird. This one is actually not possible. There's not enough information. Because if we look at this first triangle, I want to say side angle side, but where should that angle be? It should be where these two sides meet. It should be right here. But it's not there. So that's not enough information. And 5, if I check both triangles, where do those two lines meet up? They meet up right where the angle's marked. They meet up right where the angle's marked. Perfect. This one is going to be enough information to say side angle side. And now when we are trying to write our 2-column proofs, we have to prove less information. All we have to do is prove side, 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 or side angle side. And once I've done that, I've got enough information to prove congruent triangles. So please check those out. I'm going to make a second proofs video here in just a minute, and I will see you on Monday.